will be like this. Okay, that projection. So in this way, the projection of this component into x prime direction will be only this part, right? So that will be.
I'm a bit confused by your drawing.
Yes.
Converting the txy into the x prime direction, is that so you're referencing between your original x versus your x prime, or referencing off of your x prime?
So this is tau xy component, and now we project into two directions. So let me highlight this one. Let me highlight this one. So from here, are you able to see?
Okay.
Okay. So now the same thing will continue out here. So for this component, this is sigma y sine theta. That is a force and projection, which is this component here, and that is sine theta. Okay, so this plus.
So sigma and tau always form your hypotenuse?
Sigma always.
It's always, you always base the angle.
Here is the sigma, for example, you can imagine the sigma is say 10 or 20 degrees.
Yeah.
Smaller one. It'll be easier to see here. Okay. And then we continue. Now we have two, and then we fix. Now we go, for example, this one. So this one again, this one is parallel, so this one have the similar projection like that one. So here is like this. So for this component, that is the stress. And the force is tau x cosine theta. And then for this component that is projecting into that is this one. So that would take cosine. Okay, and now they fix this one. And now for this one, that has this similar. So for the last one is tau xy cosine theta, tau xy cosine theta, and then times sine theta. That's it. Are we okay? And now here we can leave a few space. So here let me summarize here. So that means here will be equal to I have to cut my answer here. So that would be sigma x cosine squared theta plus sigma y sine squared theta, and plus 2 tau xy cosine theta sine theta. And here we might be able to use the formula from trigonometry and can formulate is say sine theta, sine 2 theta equal to 2 sine theta cosine theta, and cosine 2 theta equal to cosine square theta minus sine square theta. So using those ones, so therefore we have cosine square theta equal to 1 plus 2 and sine square theta equal to 1 minus cosine 2 theta. So with those things, we can plug into using the formula. We simply plug in those information, so that will be equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y by 2 cosine 2 theta plus tau x y sine 2 theta. And I box this one because that will be the useful information for you to calculate sigma x prime. And we can repeat. So now we go to the x in y direction equal to 0. Okay, so that means right now, using this one, this is an equilibrium in force, so that means tau x prime y prime. So right now I'm looking for the equilibrium of the forces in the y prime direction. Y prime is this direction, okay? So all the force components in this direction must be in balance as well. So now we simply go over the 5 components one by one. So this one must be balanced by the other 3 projections from the other 4. So now we go one more time. So now we go this one. For this one, this component is projection into the y prime is this portion. So that portion is sine. So that will be equal to tau x y. Sine theta, that is force. And projection into the y direction is sine. Okay, so here is going upwards. So why not here is this? I take the sign convention, go to positive y direction equal to 0. So here you can see this one go to positive y direction. So positive, this go to positive y direction, positive. So here we take the sign convention. Everything should be equal to 0. Okay. And now for this one, the projection of this force into y prime direction is this one. So that one is sigma y sine theta and times cosine theta, and that is in the negative y prime direction. Okay, and now we move on to this one, sigma x prime and cosine theta. And for this one, its projection in the y prime direction is this one, and pointing to positive y prime. So sine theta positive y prime. Now the last one is this one. So the force is tau xy cosine theta, and for this one is this one. Projection into y prime direction is this component, and that pointing to negative y prime. So cosine theta negative. So we rearrange the 4 terms, then we go here.
Where did
So,
the x prime
yeah.
come from? The sigma x
X prime, what is x prime? X prime is the coordinate systems
Yeah, but why
Okay.
don't you have any other primes?
other prime.
Never mind.
Okay, never mind. Okay.
Actually, I have her exact question. Why are you so in your formulation of sum of fx, you don't reference any sigma
Again?
prime about sigma values that are, say, x prime or y prime, but then for your sigma forces in the y prime
You
direction,
suddenly get one.
you reference sigma x prime.
Is it not sigma x cosine theta sine theta? From that.
I don't know. But
Oh, you just have an x prime in the equilibrium equation for
yes.
No, below it, your finger below. Moving.
This
yeah,
one?
Yeah.
What is this one?
Yes.
That one is, oh,
Okay. Good.
I'm sorry, typo. Yes.
So I'm not crazy.
So here, therefore, let me x prime, y prime will be equal to, let me summarize from there. So that would be equal to minus x minus sigma y. Sine theta, cosine theta, plus tau xy, cosine square theta, minus sine theta. And again, we plug into the formula to simplify the whole thing. Then this will be equal to 2 minus sigma x minus sigma y, sine 2 theta plus tau xy cosine 2 theta. So right now, those are the information. So let me get rid of those ones. I don't think I need those ones anymore. Any questions before I erase this part?
Only the diagram, right?
Yes, only diagram. Okay, too late. So now again, right now you can see, let me recite our problems. We are given sigma x, sigma y, tau xy, and the orientation between the two coordinate systems. We're going to find tau sigma x prime, sigma y prime, which is a function of theta. So right now we already calculate this one and this one already from the two formulas. Okay. And now how to solve for this one? This one we don't need to repeat, or otherwise you can say select another cross section which expose the surface which have that information. But here you can try is this. So say if this is the this is our given element x, y like this. Okay, and this is a given, and now we want to orientate into here. Okay, so that means right now here we extended x prime, the orientation between x prime and x actually is the angle between here, right? Between the two sides. And from here we orientate in this way. You can see we orientate, that means actually we overlap. For example, we take this side as we join here to calculate the two informations. And now you can see if we want to get this one, and one more time, right now for up to now we get it so far is all the information on this side. And how can we utilize the result to get the information on this one, that means on this side? How can we do it without going further, repeating the same formulation?
You shifted one.
Here is the scale, is the tip. We simply rotate by, again, the two formulas about the information on this side in terms of the angle theta here. Again, the two information about this side, if I rotate this side, say, let me label it. So now we're looking for sigma y prime is here. And the formula is the formula on this one. If we will be able to turn this one by 90 degrees more, you can see the formula's information will right fit into the orientation we're looking for, right? So that means right now the formula in this new orientation is sigma y prime. So that means sigma y prime, yes, will be equal to this value in terms of theta plus 90 degrees more. Will that be okay? So using this information, we don't need to repeat. And then from here, we can do this one right away. That will be sigma x plus sigma y, and plus minus sigma y, and then minus. So there are three basic formulas for taking care of the transformation of the stress. And the sign convention. is this. For this stress, that is the tension go positive, compression go negative. And for strain stress, if we go in this orientation, that is positive. If we go in this orientation, it's negative. Yes.
I'm just wondering, on your x prime equation, after the second set, you have cosine 2 theta. Where did
Oh,
that go?
yes.
Okay,
Yeah, sorry.
it's
I,
not-
again, forgot. Okay, sine convention. And then for theta, CCW is positive. Okay, otherwise negative. So once we have the three formulas and we try to memorize the sign conventions, then you should be able to calculate the answer that be consistent with everyone else. So probably next time we come up with a few simple examples to practice, and then we go to the more circles.